record our session for today. Now we're going to use the QuantMode package. I'm sure you're familiar with this. We met this before. We had some introduction to this. So let's acquire this. Let's require this package. Okay. I'm sorry. Could you do you have the in the file that I sent you? You have the objects here, right? In the global environment. Can you see Intel, Microsoft? Could you kindly sweep that or delete that first? Let's start from scratch. So please remove all objects so that there will be no duplications. So I hope your environment is empty. Okay, so that we can run it on our own. Okay, so you know very well that QuantMode is a very powerful package and it's used for importing data. It's also used for charting, for coming up with technical indicators, computing for returns, etc. So we'll have a brief review. Okay, you remember that the get symbols allow us to get stock prices. So here we're creating an object called Apple. Okay, AAPL, and you get the symbol of AAPL. The default is this is from, even if we don't put here as SRC, which means source. Okay, source Yahoo. We know that this is indeed from Yahoo. Okay, daily prices. Okay. Okay, so let's run this. Maybe let's just remove the head. And you see, we'll have the Apple object. This is an extensible time series object, okay? And we learned before that the get symbols function of QuantMode will return the open, high, low, close prices of the stock being imported. And then you have the volume and then the adjusted price. Okay, we can do some, of course, it's good to plot this using the base R for plot. So we have here a very basic chart. You can also plot the other variables. So here we have a multi-panel. So you can see here the opening, high, low, close, the volume, all the variables that you can find in your Apple object. You can plot it in a multi-panel. All right, and then, okay, but for me the chart capability of QuantMode is a lot better. The chart series is a QuantMode function, so let's use that. This is actually a candlestick chart. We cannot see that much because our data is quite wide. Okay, I think we downloaded a 5-year data, whole of 2017 up to the whole of 2021. So that's a 5-year data. Okay, and we can zoom in. For example, let's just subset the whole month of December. And here we can see the candlestick here. Okay. So this is just a quick review, guys. I'm sure you don't. Do you have any questions so far? That's not really our.
I got disconnected. Where did you get the Apple? Did you run any code earlier?
Yes, here. This one. This line of code 25 to 31.
25.
The get symbols function.
The whole chunk, sir?
Yes. Yes.
Okay. Hold on.
Sige, go ahead.
Why?
I cannot find it.
It's
Sorry?
error on my answer.
Error? Are you
It's just
sure?
Yes, error po.
Oh, wait. Did you run the Did you run the QuantMode package library?
Not yet.
Yeah, you have to run this because the get symbols function is from the QuantMode package. And even if you have installed QuantMode in your R, it will not run unless you execute this library command. Okay, were you able to get it now, Love?
It's still loading, sir.
Okay, sige, we'll wait for you. Don't worry.
Thank you, sir.
It's okay. I'll make all of you co-hosts, okay? So that if you have questions, you can easily share your screen. Do you still want to have finals, or do you want just the two quote unquote, well, we can call it papers, technically. Hello? I think sister wants a very long finals, right? Sister?
Yes po.
You want a very long finals?
Long finals?
Long.
Long?
And a difficult finals you want, right?
Yes po.
Huh?
This
Really,
error
sir?
unexpected po.
Sister, are you sure?
No. I just confused because this is the download still error po. This is sir,
Sorry?
loading the packet.
Okay, would you like to share your screen? I'll stop first. If you're encountering any problem, I'll stop sharing first. And if you have questions, since Ronnie also, I'll make you call. Yeah, I think all of you are co-hosts. Okay. So who's encountering any problem? Love, were you able to?
This one po. This one, sir.
It's okay. Warning. Yeah, it's okay. It's okay. It's okay. Oh, no problem with that.
This is the error unexpected. This one.
Oh, wait. Okay. I thought the warning in the quant mode. Okay. Could you kindly go to, sister, could you kindly go to, right there. Macy, get symbols. Okay. Your Yahoo, you have to have a comma after that. Comma. Comma, yes.
Comma.
After the quotes.
After the okay.
Yes.
Okay. This one.
You're missing a comma there, yes.
Okay.
Yeah.
I will try.
Okay.
Po.
Run that now. Okay, Love, are you okay now? Love got lost. Love got disconnected. How about Ronnie, Rob? Are you okay?
Yes, sir. I got it.
Okay, good. Ronnie, you get
Yes,
it?
sir. Yeah.
Okay.
Yeah.
Okay, thank you. Good. Okay, so we're done with the using the chart series function of, this is from QuantMode. And as I said, you can subset the date. And here you have, we only plotted 1 month of data, December of 2021. So it's kind of powerful. Okay, is Love back? I think she got disconnected. Okay, she's here now. Okay, Love, are you okay now?
Hi, sir. Sorry, I got disconnected.
Yes.
Yep.
So were you able to
run?
Okay, good. Okay, so let's continue. Now, we want to create an object with several stock prices. Okay, I think we have not used this before. The list apply. Okay, so always if you're using a new function in R, it's always good to use the help function. You can use a question mark and then L apply. Okay, there, and it will give us some information about that function. So this is actually list apply. This is from the base package.
Sir,
Yes.
you're not
Nasa screen
your
po.
screen.
Sorry.
You're not sharing your screen, sir.
Oh, sorry. Okay. All right. So we'd like to create an object with several stock prices, and one way we can do that is to create a list of objects. Okay. So what I mean is you have Apple, and then under Apple you have all the stock prices there: the 6-1, the open, high, low, close, the volume, and the adjusted close. And then you can also have Google, Microsoft, Intel. So we created an object called tickers, and it consists of these 8 stocks: Apple, Google, Microsoft, Intel, Amazon, Netflix, Facebook, Tesla, and this is the Standard & Poor's. Okay, I'm sure you know that this is the proxy for the market. So I'm creating an object. Okay, let's just make this my stocks. No need to put here number 1. Okay, my stocks, and then we're going to use the L apply. So what's the L apply function? If you take a look at the definition of the description of the L apply function, L apply returns a list. Okay, so we want a list of the length as X, each element of which is the result of applying a function to the corresponding element of X. Okay, so our X here is our ticker symbol. Okay, so this is our X. So it says here that there are each of the same length as X. So it will create a list of objects that has the same elements as our X. Okay, our X consists of several let's say ticker symbols: Apple, Google, etc. So we're going to use that. We're going to create an object called my stocks. Okay, this will be a list because we're going to use the L apply function. And so if you look at the syntax here, it's just simple: L apply and then X, whatever that object is, and then the function. Okay, the fun is the function to be applied to each of the element of X. Okay, it can be an addition. It can be this is used in this is the pipe operator function, etc. So what we're going to do for our function, we're going to define it. Okay, so function applied to X. And what is that function? So we start with open parentheses, and you have to end with I think I made a mistake. Yeah, with the close parentheses. I'm in brackets. Okay, this is brackets, curly brackets, and then the open parentheses here, and then the close parentheses here. So can I just okay, let me see. Let me increase the font a bit. Okay, let me make it 18. Okay, can you see it better, guys?
Yes, sir.
Okay. So going back here, we have this object, my stocks. And then we're going to use the lapply function. We said based on the definition, lapply creates a list. Okay. How do we create the list? It will be applied to the tickers object, which consists of these names, and then the function. So X and then the function. Okay, the function is get symbols. So we know this function, right? This one will give us the stock prices. We're using the dates from December 31, 2016 up to December 31, 2021. It's a 5-year data, daily data. And then auto assign that false. We're the ones going to give it a name. When you say auto dot assign, it means that if it's auto dot assign is equal to true, R will be the one to give the names to the objects. But we can use the auto dot assign is equal to false and give the name to our object. Okay, so here we're saying names of my stocks, which is the object, will be just the same, Apple, Google, etc. Okay, so let's run this. We can run this one at a time. Tickers. When we run tickers, you'll notice that we now have this object tickers. It's a character. Okay, and then let's run this my stocks. And the names. Okay, so now we have this object my stocks. Okay, now unfortunately for me, I'm having problems with my R. I cannot view this. Okay, so would you kindly view my stocks? I'm having problems with my view. It doesn't register. I can't see it. Could somebody please share his or her screen? Would like to
Not
see.
yet.
Not yet. Would like to share his or her screen. I'd like to see what you have there. I'd like to check if you got the.
I can share my screen, sir.
Yeah, please, love. Thank you.
Still loading.
There. Okay. Okay, so that's what we can find in my stocks. You can see it's a list, right? Type list. Length of the list is 9. So you notice that here, the first one, it did not change the name. Okay. Can you go back, please, love? Can you go back and please run all the chunk together? Run all the chunk, the whole code
Yes,
chunk, please.
sir.
There. Thank you.
Hi, am I unmute? This one, sir?
Yeah. Run
This
that.
one, sir?
Yes. Yes. Okay. And then go to view my stocks.
This one?
Yes.
No.
Wait, could you kindly close that first? Yung my stocks, could you kindly close that? Okay. Close that first. And then run there. Okay, there. Okay. That's the correct one now. You know, it has a name, right?
Yes, sir.
The elements.
The unknown here.
Yeah, I don't know why there's an unknown there. What's the unknown there? Could you kindly click
By
that?
error.
May error. Okay, sister, I'll get back to you. Okay. Just notice, guys. Love, can you kindly click the blue arrow beside Apple? There. Error in names. Subscript out. Did you click that blue arrow?
Yes, sir.
Ayaw niya. Error. Okay. How about on the right side?
Which one, sir?
Do you see that spreadsheet on the right side?
Spreadsheet on the right side.
of Apple at the end of the row there.
This one, sir.
There. What will that give us? Could you kindly check that? Okay, it just gives us the name. Okay, it's my stocks, and then it's the Apple, Apple object. Okay, sister, what was your concern? Thank you, love, thank you.
The names of the is error.
Could you share your screen, please?
Yes, this one. Error in names.
Names, my stocks, Apple, Google, Netflix. Could you kindly go up, please? In your tickers. Okay. Down, please, down. Okay, I think you're missing Tesla there. Kindly, after FB, copy Tesla. You have to also include Tesla.
Yes, sir.
In the names, my stocks, right?
Yes.
What's the name after Facebook, after FB? At the end of the row. Apple, Google, Microsoft, right?
Yes.
Intel, Amazon, Netflix,
Amazon,
FB,
Facebook. Tesla. Oh, Tesla, this one.
Okay, kindly copy the Tesla above and paste there. So that's
Only
where
that
you,
for copy. Okay,
yeah.
po.
Copy also the comma.
Thank you.
Copy also the comma.
Yes, po.
Okay. So please run the whole chunk. Okay, Rob,
Yes.
Rob and Ronnie, were you able to get it? Were you able to create the object?
Yes, sir.
Okay. Ronnie, how about you?
Yes, sir. Yes, sir.
Okay, good. All right. So now we have an object called my stocks. Okay, so let me share again my screen. We now have this object. I have a problem with my view. It's not showing. Okay. So we now have this object called my stocks, and my stocks contains 8. Is it 8 or 9? 9, I think 9 lists, right? What are those? Those are the lists. Those are the stocks: Apple, Google, Microsoft, Intel, Amazon, Netflix, Facebook, Tesla, and Standard & Poor's 500. Now, each of them have their own columns, right? Each of them is a data. It's a data frame consisting of 6 columns. So Apple has 6 columns, Google has 6 columns, Microsoft has 6 columns, etc. Okay. Now what we want is from this list of my stocks, we want to get the adjusted price, the adjusted close of each of the 9 stocks. Okay, are you with me, guys? Hello, are you with me?
Yes, sir. Yes, sir.
Okay,
Yes,
good.
sir.
So let me run that first. Okay, here, okay, let me run head my stocks. This is a list, so okay, what happened with this code? Don't do that, guys, because that will take long. Okay. What happened to this code head of my stocks? It gave us the first six rows of each of the elements there. Okay, so the first 6 of Apple, the first 6 of Google, the first 6 of all the stocks. Okay, so that's why it gave us quite a long list. Now, however, when I just subset, when I say my stocks and then Apple, then it will just give us the first 6 elements of Apple. So if you run this, okay, so take a look at this. All right. So these are the first six rows of Apple: open, high, low, close, and then volume, and then adjusted price. Of course, if for example, I put here GSPC, this is Standard and Poor's. Okay, I think we have to put here the current. It returns an error. Okay, so we should not put the current. Okay, this is not accepted. Okay, so for oops, null. Why is it giving us null? Could you kindly check your My Stocks? Do you have GSPC there?
Still error, sir.
Still error. Okay, sister, could you kindly share your screen?
Sir, will replace the Apple with GSPC?
Yes, I'm trying to see also if we can access the GSPC. Sister, you may share your screen, please. Error in names, Apple, Google, 1, 2, 3, 4, 5, 6, 7, 8, 9. Correct? Tickers. Error in names, my stock. Okay, sister, look at your row 57. Row 57, it's My Stocks 1. Kindly remove the 1. There. Okay, then run the whole chunk. You can just use sister there. Okay. Wait, sister, kindly run the whole code chunk. You press later on. You press the green arrow on top. There. The whole chunk. And then please run view My Stocks. Okay, there. Okay, so there you have it. You have the those are nine objects. Take a look at Apple. What's the type there? It's double. It means that the elements there are integers. Okay, 1, 2, 5, 8 rows by 6 columns. Okay, 6 columns, right? That's 1, 2, 5, 8 by 6. Do you see that number? 1, 2, 5, 8 times 6. Okay, and it's an XTS object or a zoo object. Okay. Okay, so thank you, sister.
Thank you, sir.
Okay, thank you. So let me share again my, let me share the screen again. Okay, I'm checking how to get the GSPC, but I'm having a problem. I don't know why. If I use GSPC, it returns an error. If I use the caret, let me see again. But if I use, we were able to get, for example, let's use Netflix. Okay, so it gives us the elements of the Netflix object, the Netflix data frame in the object My Stocks. Okay, so let me just find out why I'm not able to get GSPC. I don't know why GSPC. So this is Standard and Poor's. Doesn't read the caret here, but if I don't put the caret and just put GSPC, it doesn't also run. It's null. It's not able to read the GSPC. Okay, anyway, that I will have to check. Okay, so what are we going to do now? We have an object called My Stocks, and then that My Stocks contain nine data frames. Okay, each of these data frames have 6 columns. Now, what I want us to do is to create another object, okay, which contains only the adjusted prices of Apple, Google, etc. So we want only 9 columns. Okay, and these columns are the adjusted prices of the 9 stocks, 8 stocks, and then the benchmark, the index, which is Standard and Poor's. So we're going to use again lapply. Okay, we're going to use lapply, and also we're going to ask R to get the adjusted prices from each of the different elements of my stocks, and then merge it. Okay, so we're going to create a list of adjusted prices using lapply and merge into one object with their adjusted prices. We're going to use the do.call, okay, do.call merge function. Okay, so let's just take a quick look at what, okay, I'm sorry, do.call function give us. It's from the base R. Okay, it says here, constructs and executes a function call from a name or function and a list of arguments to be passed to it. So it constructs and executes a function. So do.call is a function that we're going to use. And then what will it execute? The merging. We will ask R to merge the different adjusted price. Okay, so this is just the usage, the syntax, what arguments, etc. So it's a simple function. So we're going to create an object called adjusted prices. Okay, again use the lapply function. Okay, from where? From the object my stocks. Okay, and then what's the argument? Just get the adjusted price. So just get the adjusted price. So what will happen is that R will create a list. So this is a list. It's not a data frame, because when you do lapply, it will give you a list. Remember, a list is different from a data frame. Okay, a list can contain several types of items. It can contain a vector. It can contain a data frame. It can contain a matrix. Okay, a data frame is a rectangular presentation of your data. Okay, a list may have different types of data in it. Okay, so could you kindly run this, and somebody could you please share what's inside the view, what's inside? I'm sorry, I cannot. Something's wrong with my R. It doesn't show the adjusted prices. It doesn't show the object. Can somebody please? I'll stop share. Rob, can you share the adjusted price?
Yes, sir.
Thank you. Okay, could we kindly see the adjusted prices? Yeah, okay. Wait. Nag-ano ka na, no? Kinontinue mo na, no? Okay, did you run the...
Yes, sir. Kinontinue ko na po.
Okay, please go back to the code. Go back to the code. Okay, so okay, let's create another one, adjusted prices one. Adjusted prices one, and then view adjusted prices one. Okay, we just like to see before we do the merging. Okay, could you kindly run that? And then let's see what's inside adjusted prices there. Okay, notice guys, when you use lapply, it will return a list. So you should have an object that's a list, and then you're getting a list out of it. So this time, take a look at Apple. It's no longer 1258 times 6, right? Rob, why do you think it's not 1258 times by 6 now? Why is it now 1258 by 1?
Because we're getting the adjusted price only.
Correct. Yeah, that's very good. Thank you. Thank you for that. So we're getting the adjusted price only. So that's why your Apple is it's now just a unitary variable. Okay, it's a data frame, and it only contains one column. Okay, all right. Thank you, Rob. Thank you for that. Okay, so let me go back. Sharing. Sorry, let me go back sharing the screen. Okay. Now, after we have created an object called adjusted prices, we're going to use the do that call. Okay, and we're going to merge the adjusted prices into one object. I think I should have just okay. Let me just use prices here. Okay, prices. Okay, prices, so that I still maintain the adjusted prices. Okay, so here we're saying that do that call. Okay, merge the elements of adjusted prices. And we know that adjusted prices is only one row each, one column each, I mean. So when we merge this, okay, let me just use the head because my view is not working. Okay, there. Okay, there. So what do we have now? We have now just it's now a data frame. Okay, prices. If we're using small letters. Okay. So what do we have now? We have now, let me see, class prices. Okay, it's an extensible time series. It's a time series object still. Okay, and it contains the 9 adjusted prices of the 9 stocks that we brought to the adjusted prices. Okay, let me pause for a while. Any questions, guys? Clear so far? Clear so far? Any questions?
Sir, I have
Yes. Yeah, sure. Go ahead.
I tried to run the do that call chunk.
Paki-share, love. Stop share ako.
Here, sir. I'm getting an error in view. Just in view.
Object price. Okay, because you have to change the adjusted prices. The code 88.
This one, sir.
Not that one, because the name. You have to make that prices also.
Okay.
Small p because your view prices is also small p. Okay. Second argument must be a list. Okay. Could you kindly go up, please, love? All right. Let's run this again. Let's run the adjusted prices. Let's run that. There. Okay. Okay. So there you have the list, right? So let's now perform the do that call. Go back to our code. Okay, prices, do that call, merge, merge, adjust from the adjusted prices, view prices. Okay, there you are. Okay.
Yes, sir.
Okay, good. So we learned how to use the lapply to generate a list, and then from that list, get another list. Okay, because the initial list that we had, the my stocks, had several data frames in it. So for example, Apple, it was a data frame. It had 6 columns from Apple down to GSPC. Each of them were data frames, and they all had 6 columns. So what we did was to apply again, and then just get the adjusted prices of each. Okay. So from my stock, we generate, yes.
Sorry, share screen.
Okay. No, I'm not yet moving my screen. Okay.
Okay, sir. Thank you.
So I'm summarizing, guys. I'm summarizing. Okay, let me go back a bit here. let's backtrack a bit. Okay, we created an object called myStocks. Okay, how did we create this? It was an lapply. We told R to create a list. Okay, a list, and use the function get symbols. Okay, so what object? Tickers. What are tickers? Apple, Google here. Tickers is concatenating Apple up to GSPC. And then we used lapply for R to create a list. Okay, and we call that list myStocks. And what did it contain? It contained the get symbols will give us the open, high, low, close, and the adjusted and the volume. Okay. So now we have an object called myStocks, and it is a list. Okay. This list contains the different 9 objects, and each object has 6 columns. Okay. And then from this myStocks list, we got another list. How did we do it? We used lapply. Okay. So the lapply will always give you a list. So what did we get from the myStocks? Only the adjusted prices. Okay, so we expect 9 adjusted prices here. Okay, and it will be 9 objects that will go to the list. Okay, so this is also a list. Okay, if we see, guys, class adjusted prices. So let's see what type of object there. It's a list. It's not a data frame. Unlike, okay, just to distinguish, just so that you don't forget, okay, because it's important for us to understand what are the objects in, what are the different objects in R. Okay, so let me, we have the class, we have the Apple APPL, right? We have this object AAPL there. AAPL. So what's the class of this object? So this is an extensible time series. Okay, Apple is a time series, while on the other hand, adjusted price is a list. Okay, so that they're different. Okay, so what did we do next? From this list called adjusted prices, what we did was to create an object, create a data frame. In fact, we created another XTS object, an extensible time series. So what did we do? Okay, we used the function do.call. Okay, and what action did we ask R to do? Merge. Merge what? Merge the adjusted prices. Okay, and take note, the adjusted prices consist only of 9 objects of 1 column each. What were those columns? The adjusted prices of each of the stocks. Okay, if you take a look at your adjusted prices, you'll see there, for example, Apple 1258 by 1. Okay, it means that there are 1258 rows and only 1 column. Okay, so the do.call function will allow us to perform a certain function, in this case merge. Okay, so that's what we got, no? When I run the head prices, okay. So you have here Apple adjusted, Google adjusted, until GSP adjusted. So there you go. Okay. Now we have an object where we have the prices. Okay. So we now have one data frame, one XTS called prices here, which contains the 9 adjusted price of the 9 stocks. Okay, let me pause for a while, guys. Any questions? Any clarifications? Clear so far?
Clear so far, sir.
Thank you, love. How about sister? Clear so far?
Yes, sir.
Okay, Robbie,
Yes, sir.
Ronnie.
Yes, sir.
Okay, good.
Yeah.
Thank you. Thank you. All right. So let's have a review again of computing for returns, because later on, when we reach the portfolio optimization part, we will have to, it's imperative that we know how to compute returns. Okay. we can use these functions coming from QuantMode. Period returns, daily returns, weekly returns, monthly returns, annual returns, yearly returns, etc. So if we have an XTS, an extensible time series object, okay, and we know that an extensible time series object is a type of object where the dates, where the time frame is an index. So what I mean is, okay, take a look at Apple again, guys. Apple, you notice that Apple prices, the date, okay, the date stamp is not part of your variable. Okay, unlike a data frame, when you take a look at the data frame with the date is not the index. So you will see that if the object is a data frame, the date is a column, the date is a variable. So an XTS object or a zoo object treats the date as an index, which makes it really very powerful. Okay, which makes it a lot easier to work with. Before, when I would work with time series and the time series is in a data frame, it's really difficult to manipulate the data, especially because the date is considered as a variable. It's considered as one of the columns, so it makes it more difficult. Now they created objects like XTS, which makes computation a lot easier. Okay, so let's go back to our functions. You can perform this in QuantMode because you have extensible time series objects. If you were to run this using a data frame, you will have an error. Okay, so the advantage of this using QuantMode, because when we download stock prices from QuantMode, it will always be an XTS. Okay, all right. So I think we studied this before, but let's just anyway. Let's run this. So what will the period return give us? Okay, always make it a habit to do that. Calculate period return. So we have daily, weekly, etc. Okay. So for period returns, you have to identify what's the object, and then you have to identify if it's monthly, if it's weekly, etc. Type, it's either arithmetic or continuous. Okay. Now what's leading? Let's see the definition here. Leading means should incomplete leading period remain returned, be returned. Should incomplete leading period returns be returned. Okay, leading is equal to either true or false. Should leading period returns. Okay, I think I should seek more clarification about this. So sorry guys, I can't answer this now. Leading should incomplete leading period returns be still answered. Okay, if it's incomplete, okay, so that's why I chose true. Okay. Anyway, I don't like to I think I should do more research about this in the package documentation itself. I don't want to give a wrong answer to you. Okay, and it's not in the example here. Okay, what's good with using the help function is that it can also gives us examples. For example, this one, get symbols, QQQ. This is a ticker symbol. This is a stock. I don't know what this is in Yahoo. All returns, then it will give us all returns. Then period return, you can identify if it's yearly. Subset is 2003. Okay. Okay, so you can run this. Okay, but let's not do that because we already have our data. Okay. So let's get the daily log returns of Apple adjusted prices. Okay, here I'm creating an object called Apple returns, and I'm using daily return. Okay, and I'm using the Apple object. Remember, we already have an Apple object, right? we downloaded Apple a while ago here. That was our first, I think that was our first code, Apple. Okay, so let's use the Apple object. Let's use the Apple XTS. And then compute for the daily return. Daily return, then Apple, just use the adjusted price. Type is equal to log. Okay, so this is the log of the returns. If you want the discrete type, you can use arithmetic. Okay, so let's run this. Okay. Now note, guys, that the first the first row is defaulted into a 0, 0, 0. Okay. For others, it will give you an NA. Because why is this empty? Because there is no previous data. Let's just validate this a bit. Let me get Apple, then adjusted. So let me copy this one. So I'm going to get the price, Control C, Control V. And then this one, Control C, Control V. Okay, divide. Okay, and then let's get the log. Let's see if the answer is the same. So I'm validating, guys, whether the return is really the log returns. So this is value at time t, and then this is value at time t minus 1. So let's get the log of the ratios. 0.001119. Let's see. 0.00111980 0011139. Okay. Three ones and then 9 and 8. Okay. It's different, guys, because I think the figures reflected here are not the exact figures. That's why we're getting different answers. Okay. All right. Any questions, guys? Any questions? We were able to get the daily returns. So there will be many different daily returns because it will get the ratio, the log of this divided by this, and then the next, the log of this over this. That's why you have several daily returns. That's your Apple returns. Any questions, guys? Apple returns and the column name is daily dot returns. I think what I did here was to change the column names. Okay, column names of the object AAPL returns, I changed it into AAPL returns. And then what I did was I also removed the first. I removed the first row. Okay, first row. Notice that this position is the first number is always the row when you subset, and the next number is the column. Okay, technically it should be written this way, but I'm not writing the column since there's only one column anyway. Okay, so I'm just and if I don't put anything there, it means that it includes all the columns. And anyway, there's only one column. Okay, so let's run this. Okay, so now I changed the name of the variable. It's now apple.returns, and it removed also the first element, which is actually n. It's actually 0 or not. There's no entry there supposed to be because you don't have a prior price. Okay, any questions, guys? Okay, let's just continue a bit here, and then we will have a short break because I'm sure this is quite the the codes are quite many. Okay, I think this was just repeated. I'm sorry. So this is all returns. Okay, a while ago we used daily returns. Let's see what all returns will give us. All returns. Let's run this. Okay, so let me go. Let me click all returns one. Okay, so all returns gives us daily, weekly, monthly, quarterly, yearly. So if we scroll down, for the weekly, we have the Friday returns. It's the average of the whole week. Then for monthly, this is every month. And then quarterly, every 3 months. And then yearly, of course, every end of the year. Okay, so that's your all returns. You can get the all returns easily. Okay. Now, these functions, this one, the monthly return, period return, etc., they will only work for univariate data. What do I mean by univariate data? For just one column. Okay? For just one column. Okay, so let me illustrate that here. Okay, take a look at this. So I think we replace it by prices, right? What's the name of our? What's the name of our? Here, prices. This is the name of our data frame that contain all the 9 adjusted clauses. Okay, let's try to here. Let's try to run this. Not the adjusted prices, but the prices object. If you change it, okay. But if you didn't change the adjusted price, then it's okay. You should not change that. All right. Take note, guys, that the prices object. Where's the prices object? This one. Prices object. It's an XTS. Okay, just to show it again. Apple adjusted, etc. So this contains the adjusted prices of the 9 stocks. Now, what if I want to get the let's use monthly returns. Monthly return. Control C. Can I get the monthly return for all those nine stocks? Okay, not monthly returns. Monthly return. Enter. Okay. So is this correct, guys? Is this correct? What do you think? Is this correct? No, it's not correct, guys. It's not correct. Why? Remember, prices is it's an XS object consisting of 9 stocks, nine columns. Now, if we're going to get monthly returns for each of these stock, okay, it's wrong to use the monthly return, daily return, etc. Because these functions will only work for one for a univariate variable. Okay, that's why it worked for the Apple XTS, but only the Apple adjusted price. Okay, so if you want to use the prices here, for example, then you have to specify, for example, Google.adjusted. Then that will work now. Okay. So let me go back here. What's that? Okay, here. Monthly return prices. Then I have specified just one one variable, for example, Google. Okay, then in that case, this will work now. So let me run this. Okay, so now it works. Okay, so this is the monthly returns for Google. We can validate that. Okay, my point a while ago was that you cannot use an object that has several columns with this monthly return, weekly return. Okay, so let me remove this because this example was made to highlight that. Okay, this clarification here. Note, functions above the returns are only for univariate data. Getting the returns of a portfolio of stocks, e.g., for our data frame, okay, this should now be prices. Okay, prices will not give the returns of all the stocks. Okay, is that clear, guys? Okay, so let's just finish this a few other functions, and then let's have a break, huh? Because I know that this is quite tiring. This okay, so where do we stop here for the break? Okay, still quite a number of lines. So let's go here, guys. Okay, I don't want to stop here because it will destroy the flow. Let's just finish this portion. Okay, now what if I want to get all the returns of the stock prices in our object, in our data frame? So we have this object prices, right? We have this object prices, and we have this object prices, and it contains the nine adjusted prices of the stock that we downloaded. I cannot use weekly return, monthly return, all return, period return. We cannot use that. If we're going to use it, then we have to do it individually, one by one, by column. But there's another powerful package, which is the performance analytics. So kindly acquire this. If it returns an error term, it means that you have not installed this. So kindly install. But I think we have already installed this. Okay. Sometimes it will give us comments like that. All right. So have you acquired the performance analytics package? Guys. Are you okay, guys? Have you run library performance analytics?
Yes, sir.
Okay, thank you. Sometimes again, guys, it's helpful. Okay. Or you can, let's check this performance analytics package. Okay, here. So what does this do? A lot, guys. Econometric tools for performance and risk analysis. For performance and risk analysis of financial instruments or portfolios. Okay, so if you want of course, you can download the PDF file about this, and if you want the functions here, there. So many functions that you can use. You have CAPM alpha, CAPM beta. So this is a very good package for investment analysis, even for regression or statistical analysis. There. Okay, so many functionalities. Okay, we're going to use the return that calculate. So let me just look for that. Return that calculate here. Return that calculate. It calculates simple or discrete or compound returns from prices. So if I click this, okay, so this is the usage. It calculates simple or compound returns from prices. So return that calculate prices. The prices here can be a data frame. It can be an XTS object. So it can be several columns, several variables. The method method can be discrete, log, or difference. So it can also be calculate returns. It's the same. Okay, same thing. Calculate returns or return that calculate. So here, I'm using return that calculate. And then I think I changed the name to prices. Okay, prices, and then method can be log. I'll use log. Okay, so I'm creating an object called stock returns. Okay, I used performance analytics to get the log returns of all the assets, of all the stock prices in the prices object. So let's run this. Okay, now take a look, guys. There. Ito na, lahat, no? All of them were computed. All the log returns were computed. All the elements, all the columns of our price object were computed. Okay, so here I just remove the first column, the NA. Let's just remove that, NA. So it's stock returns and then stock returns -1, the first row removed. So that it's now there. It removed now the first column. Okay, now there's another way. This is also a good way. So here, it's very easy. Don't have to worry about having to compute each of them using QuantMode. That's why QuantMode and performance analytics, they're combined together, they are powerful tools. Okay, stock returns. Okay. So what's the second method? Okay, we can use the QMOW. Okay, we can use the QMOW. I'll just fix this first. Oops. Why isn't it? Anyway, okay. If you haven't installed DevTools, kindly install it. Okay, you can check, guys, here in your packages. If DevTools. Okay, if you don't have DevTools, then you can, of course, you can install it, and then let's require it. And then I want you to also install this. Okay, run this chunk of code because we want to install the QMOW because we're going to use some of the functionalities of QMOW. And let me just illustrate that. And after this, we'll have a break. Okay, so kindly run this and then this, and then please tell me if you were able to run QMOW. we need to use this dev tools and install that GitHub because the QMO package is not yet housed in the CRAN, the Comprehensive Archive Network. So we will have to get it from the site of the one that created this this package. Okay. Are you error?
Yeah, and devs tool.
Sister, can you please
And-
share your screen?
Okay, bro. Wait. So this this one.
Okay, so go up, please. Go up. Please remove the, look at your install that package dev tools. Kindly remove the hashtag sign there. Please remove the pound sign in row 183.
Row 183.
Yeah, because you haven't run dev tools yet. Remove the pound sign there. Pound sign.
Or,
Pound at the beginning. That sign, that hashtag.
oh, this the hashtag.
Yeah, the comment sign there. Remove it.
This one.
I added it because I thought we installed it already before. Okay. So could you kindly run that again, please? Run the code, the chunk. Yes, please. It takes a little time. That's DevTools, okay. That's QMOW. Let's wait to repo. Okay, enter. Could you kindly go up in your console, please? In the console side, on the upper right side, console. There, sister. Yeah, there. Kindly scroll up. All. Okay, kindly go down. Okay, so because you're asked for options, just type one, all.
Enter one more numbers.
Yeah, one. Type one.
Type 1.
Yes, because one is all.
Is about. This
No,
one.
not there. On the right side, enter one or more numbers.
This one. Huh?
What happened? Did you write one?
Yes, po.
Okay. Let's just wait for it.
This is yes.
Where? It's still running. Let's wait for it.
This asks, do you want to install from source the package snip compilation?
Where? I can't see it.
Yes.
There. Where is it?
You cannot see it
No, I cannot. What?
in my screen. Just
What?
do you want to install?
Where?
From
Which
sources.
side? Which side? Could you kindly point to it with your mouse?
This one, I already.
Do you want? Where's that? Do you want? I don't see it.
Really? The
No.
question in our screen, not available in your screen. Sir.
No, I don't see.
This is question. Do you want to install from sources the packets with snip compilation like that?
Yeah. Okay. You can press yes. Okay.
Yes. Okay. Lang.
Yes. How about the rest? Were you able to upload the files, the packages, guys? Love, were you able to do that? Rob, Ronnie? Okay na, sister?
Yes.
Rob,
Still
Ronnie?
running.
Yeah, just wait for it. How about Robbie? How about Ronnie?
Do it.
Sorry?
Running.
Ronnie, okay. Rob and Love, were you able to install the package?
Yes, sir.
Okay, so let's just wait for your classmates. If you're done, guys, kindly please chat that you're okay so that I know when to continue. Everyone okay, guys?
The library of Kama,
Yes. Kiamao, yes.
error po.
Error.
Yes po. Error in library Kiamo.
Let me
No
see.
packet.
Okay. Can you share your screen again, sister?
Oh my goodness, what happened with ours?
With what?
Not yet. This one. Error. What was that? What is it? This one.
There's no package. Okay, could you kindly go to the packages section?
The packet, this one.
Packages. Lower right. In the packages window, in the files window pane.
Files.
There you have packages, right? Files, plots,
Yes.
packages. No, right side, sister. Right,
Yes.
lower right there. In that window, there packages. And then please type QMAO here in the search there.
QMAO.
So
Not
not yet. Okay. So kindly run separately line 190.
This one.
Run that, please.
Run.
Yes, just that line. Control enter.
Yes.
Okay, and then run the library.
Done.
Okay, it's okay now.
Thank you.
Okay, how about the rest, guys? Are you okay, Rob? Are you okay, Ronnie? Are you hungry? Are you there?
I think so.
Yes, sir.
Maybe you're not there. Okay, just quickly before we go on a break, short break. The QMO package is quite powerful because it can make use of make price frame and make returns frame data directly. Yeah. Okay, so for example, okay, here we're going to get the Okay, let me explain myself first. You notice that we don't have the Apple, we have the Apple object in our data, but we don't have Facebook, we don't have Intel, we don't have Tesla, we don't have it individually because we did not download it individually. What we did a while ago was to download it as a list from my stocks, but we don't have it individually. So here, let's first download it individually. So we're using the get symbols. Remember the tickers object that includes everything. Okay, the 9 stocks, and then same date, daily periodicity, and auto.assign is equal to true. It means R will give the names automatically to it. So let's download this. Let's run this. And then it will give us the 9 stocks individually. So which means that we will now have here, okay, there, we now have Amazon here, Facebook, Google, GSPC, Intel, Microsoft, etc. Netflix. Okay. So I hope you're following me, guys. Okay, so we now have these 9 stocks here in our object. So we can now get them, we can now access them individually. Okay. Now what we're going to do is we're going to use the function make price frame function. Okay, maybe let's first look at QMOW. Oops. The QMOW package, QMOW package. Okay, this it's an add-on. Okay, so it's an add-on to the QuantMode package. It's some QuantMode-like functions, often useful when working in the QuantMode framework. Okay, it was made by Garrett C. Okay, let's take a look at the index. Okay, so there are several functionalities here, a lot of them also. Okay, for example, this one, make price frame, which is also PF, same as make price frame, or make return frame, which is RF, same thing. Okay, here we're going to make use of make price frame. Okay, now I'm creating an object called PF. Okay, so let me see, let me just fix this. Okay, so make price frame, that function merges the adjusted prices or returns of adjusted prices of several symbols. Okay, just like the one that we did a while ago from performance analytics. Okay, so we're going to make use of the tickers object. Okay, same date. We prefer the adjusted prices. Okay, and let's view this price frame. Okay, error in no data. Okay, so sometimes this can be a problem. Wait, let me check the GSPC. I have the GSPC already. Okay, so this is my GSPC. Okay, let me run it again. I noticed that for the make price, when we're dealing with GSPC, sometimes we have problems with it. Okay, again, GSPC again. Okay, let me just check the tickers object. Are you encountering a problem also? Where's my tickers? Why don't I have my tickers object here? My ticker symbol is not here. The tickers object. Run this tickers. Okay, it will not appear because it's just a list. So let me run that again. Okay, error again. Error with the GSPC. No data in the global environment for GSPC. Okay. Let me run this again. Okay, I have here GSPC. Okay, it was already downloaded. So let me run this again. Okay. Are you having problems too, guys? With the make price frame?
Yes, there's still error.
Yeah.
Yes,
okay.
sir.
Okay, so let me try to resolve that first, and then I'll just the objective here, guys, is to what this will do is that it will get from the, remember tickers, guys, is these are tickers. Is it class? Oh, these are characters. Okay, I think okay. So let me think through this during the break, okay? Because tickers is only character. So let me change that first with okay, let me just change it with the object name itself. Sorry about this. What row is that? So here. Let me change the tickers with the names of the stock itself. Okay. So I replace the tickers with the names of the assets themselves because we already have the names of the assets here. Okay, we already have the names of the assets here. Okay, so let's now so if I run this, what happened? What's wrong here? From. Okay, anyway, let me check that first. Yeah, sorry about that. So we're having a problem with that. And we will have a problem with this also with the RF. Okay, what this code does is that it will get the prices. So you have this object, separate objects. We can get the prices from, we can get the adjusted prices from each of them and make it into one object, one object PF, and we can automatically get the returns also. Make return frame or the RF function, they're the same. This one, return function, here, RF. What it will do is it will get the, it will look at these objects from the tickers and then get the returns, compute for the returns. Okay, because these are prices, it will automatically compute for the returns. Okay, so let's end there first. The next part will be all about portfolio. Okay, so shall we have a 10-minute break, guys?
Yes,
Yes,
sir.
sir.
Okay, so yeah, 10-minute break. Okay, thank you. So let me pause the recording for a while. Please remind me about the recording later. I'm pausing it first.
Yes, sir.
Okay. Pause. Okay, I think I found my mistake. Okay. So here, so we can choose the ticker object. Okay, because it says here that the make price frame, okay, you should identify the symbols. Okay, so the symbols, so here I'm combining Apple, Google, Microsoft, Intel, Amazon, Netflix, Facebook, Tesla, and GSPC. Make sure that you don't have the caret, because if you have the caret, it will give us a an error. Okay, let me just quickly tell you what we're doing here. What we're doing here is we are collecting the adjusted prices from Apple, Google, etc., making use of the make price frame function of the QMOD. Okay, it's the same as PF price frame. They're the same. Okay, so make price frame and PF function are the same. So let's run this. If I run this, I'm creating an object called PF price frame, and then I'll run this whole code chunk. Run. Okay, there. PF. There you go, guys. So I now have this XTS object of the adjusted prices of the 9 stocks. Okay. So if I use, you'll get the same, guys, if you use the PF, but remove the caret symbol. Okay, that's where the error came from. Okay, so if I run this, I'll get the same. Okay, run it. There, also the PF, same thing. Okay, now if you want to get the returns, okay, if you want to get the returns, okay, this one also, we can use the make return frame. Make return frame, okay, and it will give us the returns automatically. It will give us the returns automatically, and then again, depending on the type of return that you want, I'll choose continuous. Okay. If you want the discrete return, you use discrete here, and then let's view this return frame. Run this. Okay. You now have this returns. Okay. So from the different objects, different data, different XTS objects, you can combine them and automatically get the returns from them. Okay, of course, we can remove the first row because it's NA. So if I, okay, so that's it, guys. So same thing as the one above, but this time we're using the QMOD function. Okay, you can also do the same thing with the RF function. Okay, so let's now go to portfolios. Okay, as you know, as you learn from portfolio management, the reason why it's best to have a portfolio of stock as an investment, what's the main reason is it helps in mitigating the risk of the assets. If you only have one asset investment, if you only have one stock, then in bearish economic situations, then you'll be losing a lot, because since you only have one stock, and especially if that stock tracks the market, then when the market is down, you will lose value also of your asset. Okay, so here what we're going to do is we're going to use the RF function, the RF object. Remember, the RF object is a collection of nine stocks and their returns. Okay, that's the RF object, and we'll just get we'll just get the first two. So let's call the object port 1, portfolio 1. Okay. From the RF object, we just get the first two. So we'll just have an example of a 2-stock portfolio. Your project, guys, will involve having a 10-stock portfolio. Of course, there should be no repetition of stocks. I will create a worksheet for you to identify the stocks that you're going to use as part of your study of portfolio optimization. Okay, so port 1. Let's just get the. This will give us just the first 2 columns. Head. Okay, so it's just Apple and Google.
Excuse me, sir.
Yes, sister.
I still can find the error the first time before break.
Okay. So let me stop sharing. Could you please share your screen?
So very fast and I cannot
Sorry.
follow it. So
Sorry.
very fast. So about the.
Okay, I'm sorry,
first
sister.
one.
Sister, will you forgive me for being very fast?
This one, the first one before break. We have,
Yeah, we changed that. We changed it into. We changed that already. So please copy. Could you go down, please? I think it's in. Did I change the RF? Could you copy that C? That C,
Yeah,
Apple,
okay.
Google.
Okay lang. So I will try to.
Yeah, but before, sister first. Wait, sorry.
Yes.
Share your screen first.
Yes. Po.
Sister,
Yes. Po.
please share your screen.
Yes.
Copy the list of stocks. But for GSPC, you have to remove the caret symbol.
On the GSPC to remove.
Yeah,
Before I try, but still error. This one though.
Yeah, copy that whole one, everything there. Copy that. Copy and then paste it. Replace the tickers.
Yes. Po. This one.
Make price frame.
This one.
Okay, replace the tickers there. And then for the GSPC, remove the caret.
This is
The caret symbol.
this one.
Yes, that one. Okay, then run it now. Run the whole code chunk. Okay, there.
Okay, thank you.
Okay, so do the same for the others.
Sorry,
No, it's
very
okay.
fast I cannot.
No, that's okay, sister. My fault. My apologies. Will you forgive me, sister?
Yes, po. Thank you.
Sorry about that. Sorry for being fast. Okay.
Thank you.
Thank you for pointing that out. Good. I appreciate that. Okay. So, sister, you also please run the RF because that's what we're going to use. Okay. RF. So again, make use of the make return. This time, the make return frame and copy the list of stocks. Make sure to remove the caret symbol in GSPC. Okay.
Yes.
And then remove the first row here because the first row contains NA. So you should be getting this XTS object. 1,257 entries. The original one was 1,000 for the prices 1,258, but we're removing one row because when we're computing for returns, okay, one row will be eliminated because these are periods. You got it, sister?
Yes, sir.
Okay, good. So you now have your RF object because we're going to use that. Your RF object you should have removed the first row. Sister, okay?
Yes, po.
Okay, so now we're going to create an object called port 1 here. I'm in row 260, if we're the same rows, around 266, 265, ganyan. we're creating an object called port1, and we're subsetting the RF object. We're just getting the first two rows. Okay, so we're going to get Apple and Google. We're going to create a portfolio of two assets. Okay, why two? Okay, to make the example simpler first. For your project, you'll create a portfolio of more than two. And you will have to also plug the efficient frontier. Okay, the efficient frontier. All right, so here we have, okay, so I just run the head. So we have two assets, Apple and Google. Okay, so that's our port1. Now, when we create a portfolio, we need to compute for the returns and the risk of the portfolio. What happens in a portfolio is that the returns will be lower than the highest asset. And of course, it will be higher than the lowest return asset. But the main thing with the portfolio is that the portfolio, the risk of the portfolio will be lower than any of the assets. Because that's what happens when you diversify your asset. The objective of, according to, I'm sure you studied in your development theories in finance, the MPT theory, the modern portfolio theory by Harry Markovits, that you can minimize risk. You can minimize risk by adding more assets in your portfolio. Okay, so here we're creating a two-asset portfolio, and then let's compute for the returns of the portfolio. We can make use of the return that portfolio function. We used this a while ago, okay? But we will have to identify, no, sorry, we didn't use return that portfolio. This is the first time we're going to use this. So we can use performance analytics to compute for the return of the portfolio, okay? Of course, we have to have a portfolio of returns, and that object is port1. Okay, so this is our portfolio of returns for Apple and Google. So we're creating an object here, port1 ret, okay? And then we're using the return that portfolio from performance analytics package. Our object is port1, okay? Port1. And then we have to identify the weights, okay? 5%, 5%. By the way, Rob, if you need to go, please do so. Don't be ashamed, okay? I know you have schedule work there. So just feel free to leave the class. Okay, so 0.5, no, ibig sabihin, it means that we're going to give a weight of 50% for Apple and 50% for Google, right? So may I see this prices? Okay, not the prices, but stock returns. Okay. So what will happen is that since where's port1? Where is port1? So let me just delete some of the quite a lot of objects here. Okay, let me just view port1. So here's port1, guys. These are our returns for January 4, January 5, January 6, etc. How do you compute for the returns of this? Well, very simple. Since we know the weights, 50%, 50%, it will just compute 50% times this one, 50% times that one, okay? And then add. So we now have one return for our portfolio, okay? When we compute for the portfolio return, it should be one return for that specific date because we're multiplying the weights to correspondingly to the returns of the asset. So 50% of this plus 50% of the Google returns. That's what we expect to get. And we'll have several returns because we have several different days. Okay, so this is what happens. We use return that portfolio and 50-50 weight, and then let's view the port1 return. Okay, so this one, guys, you now have one portfolio return. So how was this computed? 50% of Apple times 50% of Google, and then add. Okay, so very easy, guys. Now, the assumption here is that for your port1, for this one, you're going to maintain the 50-50-50-50 weight throughout the 5 years. Okay, is that a sound idea? Of course not. That's a very poor idea. Now, in investment, it's always a good practice to do rebalancing. When you do rebalancing, you look again at your portfolio, and you try to see if you should now change the weight of your portfolio. Change the weight because the prices are changing. Okay, the prices are changing and the returns are changing. So you would want to rebalance your portfolio. Okay, and I have here I have shared with you here this is a good simple explanation for rebalancing your portfolio from Investopedia. Okay, so I leave that to you guys. I leave that to you. So just read on the importance of rebalancing. Rebalancing means changing your weights. It's not a good idea that for the past 5 years, your weight is just 50%. Okay, so we're going to create an object now called Port1 Return Rebalance. Okay, so this is different from the one above where we just use 50% for the 5-year period. This one, we're going to compute for the return that portfolio. Okay, this is also from internal from performance analytics. However, okay, we will have to add this function rebalance on. Okay, and let's first use rebalance on every month. Okay, but normally it's not really every month because rebalancing can also be expensive because of course you will have to buy and sell the stock. Maybe sell a portion of the stock and buy a portion of the other stock. Okay, because that's what happens when rebalancing. And of course there will be some cost to that, taxes, for example, etc. Okay, transaction costs, etc. So it's not also a good idea to keep on rebalancing, let's say weekly. Maybe that's not a good idea. So let's just, for others, it's just even every 6 months. For others, even every 1 year, especially if it's a long-term investment. Okay, rebalance on, let me just put this on the next line. Rebalance on month. So let's look at the Port1 rebalancing. Let's run this. Okay, now let's compare this with Port1 Ret 766. Okay, this one is 76, still the same. But you notice, since this is monthly rebalancing, if I go after the end of the month, okay, February 1, take note of this. December 10th, 31 is negative 4.58. February 1 is 2.93. That's for the no rebalancing. For this one, December 30, January 31, 4.58, the same. However, guys, February 1, it's now different, 2.89. Okay, 2.89 for the rebalancing, that's the return. For the other one, February 1, that's 2.93. Okay, so it changed. Okay, the return changed because there was rebalancing. Okay, so when you rebalance, there will be changes in the weight and then changes in the returns. Okay, so let's run this. What we're going to do now is we're going to compare the two. We will compare the Port1 return rebalance and the Port1 return no rebalancing. Okay, we will use the Sharpe ratio. If you recall from your other finance subject, the Sharpe ratio is your standardized return. So you just compute for the log return minus the risk-free rate divided by the standard deviation. We will assume that our risk-free rate is 10%. Okay, so this is our code for that. So we will be creating this object all, so that means all the rebalancing and no rebalancing, all Port1 returns. We're going to bind Port1 return and Port1 retail rebalancing. So let's do this. Okay, let me run this first. So where's our all? Let me access the all portrait here. Okay, so what it did was to put side by side the two returns. Okay, that's the cbind function, column bind. Okay, And then let's change the names. Let's change the names of our all port 1. Let's call this the non-rebalanced, and this one is the rebalanced. Okay, so this is the function column names of all port non-rebalanced and monthly rebalanced. And then we will ask R to compute for the annualized returns. Okay, the annualized returns, you compute that by dividing the returns by 252. Okay, the monthly returns. Okay, and then we use the risk-free rate of 0.1. So when we run this, guys, okay, here you have a table now comparing the performance of your non-rebalance and the monthly rebalance. So the annualized return for your non-rebalance is 32%, while for your monthly rebalance is 33%. So you notice that for the annualized return, for the monthly rebalance, it's higher. Okay, it's higher, and the risk is lower. 26.7% for the non-rebalance and 26.23% for the monthly rebalance, giving us a higher Sharpe ratio, because Sharpe ratio is the ratio of the return per the adjusted return, adjusted because we're subtracting the risk-free rate, okay, divided by the standard deviation.
Sir,
Yes?
sorry, I got an error.
Yeah,
can
sige.
you share
Share nga muna. Kindly share your screen.
Here, sir. Ay.
Okay. All port 1. Wait, kasi nag-error dun sa taas, ano?
Opo.
One error in return, port 1, rebalance on months. Okay, return that portfolio is from portfolio analytics yan, di ba? Performance analytics. Have you loaded performance analytics?
No, hold it, sir.
Sige, library, kahit nasa ano na lang, sa console na lang. Library Performance Analytics. Capital P, open parenthesis, Performance Analytics, yan, there. Tab na lang, tab, yan. Enter mo, control enter. Okay, sige, back to yung sa ano. Diyan sa, yan, there. Did you run already the, ano?
Okay.
Did you run yung rebalance? Wala pa?
I did, sir, but I got it.
Yan. Run mo na yan.
Yeah.
Ayan, okay, good.
Thank you, sir.
Okay, thank you. Okay, any other questions, guys? Thank you for your questions, guys. I appreciate that because that tells me that you're there, you're in the moment, you're with us in the discussion. Okay, so you can see here the difference between a non-rebalanced portfolio. Just 50% there, all throughout the full period. That's a very, very poor way of managing your portfolio. In your portfolio management, did you discuss something about rebalancing of your portfolio? Love and Ronnie?
Ronnie.
Ronnie?
I can't remember.
No, love is better.
Ano? What, Ronnie? None? No rebalancing?
Robbie's sister, can you remember? If we already have discussion, I can't remember. It's more on returns, sir, and fixed income.
Fixed income.
But you can see here, guys, the power of R, no? Grabe ang power ng R. In spreadsheet kasi, well, spreadsheet is okay, but you have some limitations on that. Imagine doing rebalancing with Excel spreadsheet. Wow.
Yes, sir.
You have here how big is our data? 1,257. Imagine computing for the average returns every 30 data points, every 30 days, because it's monthly. It will take you days, okay? And that's really prone to error. With this one, guys, we were able to compute for the returns with rebalancing on a monthly basis, okay? Just for trying, what if we do a quarterly basis? Let's just see what happens, okay? If we do quarterly basis for rebalancing, let's see. Is it quarter? Yeah, they're quarters, okay? Quarters. Yeah, let's just see, guys. No need to change the title. Okay, and then let's compare. Let's see if quarterly is better than monthly. So I'll not change the title anymore. Okay, so let me run this. 0.3326.26.78. 3326. Okay, so the monthly rebalancing was better. The quarterly rebalancing had less returns and I think a higher risk, if I'm not mistaken, and a lower Sharpe ratio. Okay, so let me put that back. Months. Okay, so continuing, guys. All right. Okay, so that was a very crude way to do portfolio analytics, portfolio optimization. In real portfolio optimization, it it works like an optimization model where you identify your decision variables, you identify your constraints, you identify your objectives. So we are now going to the formal optimization, where the objectives can be to minimize the variance and to maximize the mean. Okay, so that's why we call it optimization. The first two examples, we did not read the example on monthly rebalancing. This one, we did not really do optimization. That's not optimization. So in this portion, we won't be able to finish everything here, but I would that you try to work on the other codes. It's only up to 713. Konti lang. Okay. And there are some codes here that I will have to still to check because I tried them a while ago. I was working on them. It ran before when I was using this, but I don't know why. Maybe there were some changes in the how the code or the package is run. Okay. Of course, guys, you're familiar with efficient frontier, right? Are you familiar with the efficient frontier?
Yeah.
Run?
Yes, I remember familiar.
Okay. Okay. If you have forgotten, please recall that. Okay. All right. So let me just give some introduction about this, and then we'll finish this next meeting. And then most probably, guys, next meeting will be our last meeting because I want to give you time to work on your quote unquote mini project. And then let's just discuss when will be the submission of the mini project. Okay, because I have to have some basis for the grades. Okay, so let's do this. Okay, these are the steps. I tried as much as possible to summarize it. Step 1, okay, is define the portfolio returns to be optimized. It means that we have to prepare the data. Okay, prepare the data, and the data should be returns, portfolio returns, just like what we did a while ago. The port 1 object, that's what I mean by that. So we have to have this object. We have to have our data of returns. So that's the first step. Second is we're going to identify the constraints. Okay, I'll explain this in a while, and then add the objective, and then we optimize the portfolio. Okay, extract the weights and other measures, and then we generate other outputs as needed, like charts, tables, etc. we're going to make use of the portfolio analytics package. Okay, so this is different from the performance analytics. So let's just portfolio analytics. Oops, that's why it's wrong spelling. Oh yeah, portfolio, that's correct. Okay, so this one, portfolio analytics packages. So it's really for numerical methods for optimization of portfolio. Okay, so there are different methods for optimizing portfolio, different optimization methods. Can be random, it can be DE or differential evolution. This is particle swarm optimization. I haven't used this. Generalized simulation, quadratic programming, etc. So this is the differential evolution. This is random. This is the particle swarm, etc. So these are the okay. So let me leave you to read through this. Okay, just get an idea what this portfolio analytics does. Okay, I actually summarize this here. Okay. I think at the onset we already installed. We already acquired. Where's that? Oh, not yet. Okay, so the first step is okay, actually this is, I'm sorry about this. Okay, I think I should, okay, define the portfolio returns to be optimized. This should be step 0. And then the step 1 should be create a portfolio specification object to collect specifics about the portfolio. Okay, so that's step 1. So let me just insert it. Please make sure you run the portfolio analytics. So step 0. Step 0. Okay, so what's our object? Okay, our object, so let me put this here. Control X. So this should be here. This should be step 0. Okay. In this example, we're going to use the port 1 object. If you recall, what's a port 1 object, guys? It's the Apple and Google returns. So we'll just focus on a 2-stack portfolio. For your take-home project or assignment, you will have to use a 10-asset portfolio. Okay, of course, we're going to use this model and generate a portfolio that minimizes risk, maximizes returns, and other objectives. Okay, then we define, guys, step 1, we define the specification. We define that object where we will put all the specifics for our optimization. Okay, so that's port. We call it port spec 1, and we're going to use this function portfolio spec. So let me just show you. Always helpful to see what this object is all about, this function is all about. So that's portfolio.spec. Okay, so briefly, the portfolio object is created with portfolio.spec. The portfolio object is an S3 object of class portfolio used to hold the initial asset weights. Okay, so what's contained in this portfolio spec object? It will contain the asset weights. Remember that in a portfolio, we need to identify the weights. It will contain the constraints, the objectives, and other informations, other specifics about the portfolio. Okay, the only argument to portfolio.spec is assets. All right, so this is our object portfolio spec 1. We're going to use the portfolio spec, and assets is equal to the column names of port 1. Okay, so our assets are, what's in port 1? The column names of, where's port 1? There, Apple and Google. Okay, so they will be our assets, Apple and Google. So let's run this. Okay, right, which means I have not run our portfolio analytics. Make sure to run your portfolio analytics. Okay, so that you can run the portfolio.spec. Okay, here. Okay, there guys. Portfolio.spec, portfolio spec 1. So what does it contain? So far, it just contains the Apple, the names of the asset. So let's do this view. Port spec 1. Let's try to view it in a spreadsheet here, there. Okay, so these are the elements of your port spec 1. Okay, so far, you have the name of the assets. Okay, the two assets, the Apple and Google, and you have the weight. This is the default weight. Okay, default weight, and we have constraints. No constraints yet, no objectives yet. Okay, but this is the it's like a bucket. It's like a container for all the specifics about your portfolio. Okay, so let's move on. Okay, then we add the constraints. So what are the constraints? There are several types of constraints that we can put into the model. Number one, full investments. What does full investment mean? It means that the weights should be equal to exactly 100%. Remember a while ago, we used 50% Google, 50% Apple. So that's a full investment because the total of the weights is 100%. Now, sometimes when we put the constraint to be equal to 100%, sometimes the model is not able to run it. So we might need to relax the constraint a bit by giving it a range of minimum of 99%, for example, and maximum of 101%. We may do that just to relax the constraint because this constraint is really very restrictive. Okay, next, weight sum. Weight sum, guys, when we want the when we want the total weight to be either a particular weight. For example, we can put the weight sum. Okay, this should be here. Okay, Control X. I'll put that here. Okay, here. Weight sum, we can put the minimum at 99 and the maximum at 1.1. So as I mentioned a while ago, this is to relax this restrictive constraint that the weight should be 100%. Okay, next. For this one, box. What does box mean? Box will allow us to give restrictions to the weights of the asset. If, for example, if we don't put this restriction, what will happen if, for example, we're maximizing returns? If we're maximizing returns, what will happen is that it might load all the weight to the asset with the highest return. Okay, I hope you're getting me. For example, if Apple has an average return of let's say 10%, and Google has an average return of 8%, then if we're trying to maximize the returns and we don't put any control or any constraint as regards the weight of the asset, then what will happen is that it will load everything, the 100%, to Apple, because Apple has the higher returns. And if you want to maximize the returns, then we should put more to the one with the highest returns. But if we do that, then that means we're not creating a portfolio anymore. It's just a single asset because everything is loaded to Apple. Okay? Do you get what I mean, guys? Am I making sense? Kindly respond, please.
Yes.
Sure?
Yes, sir.
Okay, thank you. And then lastly, long only. Okay, so ibig sabihin, guys, walang short position. Short position. Long only means positive lang dapat yung weights natin. All the weights should be positive. Okay, so these are the constraints that we can have. Okay, so let's now continue, guys, first to step 3, step 2. Okay, by adding constraints. Take note, we're still using port spec 1. Remember, port spec 1 is a catch-all the object where you add the asset, you add the constraints, you add the objectives. So we'll just keep on adding to that object port spec 1. Add constraint. Okay, so the function is, what's our portfolio? Our portfolio is port spec 1. Okay, so we're using the previous port spec 1 because in that port spec 1, we have there the assets, Google and Apple. And then type is equal to full investment. Okay, so this means that if you add the weights, it should be 100%. Then second, another constraint. Okay, type is long only. What does this mean? It means that the weight should only be positive. And thirdly, okay, we use the box type, which means we're going to limit the minimum and maximum. So here, maybe let's put a minimum of, let's say 20% and maximum of 70%. Because if we put 0 here, guys, if we put a minimum of 0, then it means that an asset can be 0%, which means that, no, it's okay pala, guys, kasi we're putting a cap at the maximum. So no asset can have a weight greater than 70%. Okay, so no problem, even if we put minimum of 0. Okay, so these are our additional, these are our constraints. So it should be full investment, which means the total weight should be 100%. Long only, the weight should be positive. And box, which means the weight, the maximum weight that we will be given to an asset is only 70%. So hindi pa pwedeng, it cannot be more than 70. Okay. All right. So let's run this. Run. Okay. So we're adding more to our portfolio specification. Okay. So let's see now our port spec. What happened to our port spec? Where's my port spec? It's here. All right. Port spec. Okay. Let me just adjust this port spec. View port spec. Port spec 1. Repeat this. View port spec 1. Okay. So now we have, guys, take a look at this. Assets, dalawa. Okay, look at the constraints. No? Our constraints, we now have 3. Okay, so if I click this, see, 1, you have the weight sum constraint, you have the box constraint, okay, box, the minimum 0 and the maximum of 70%. Okay, so we have the constraints here now. How about the assets? If I click this, okay, so you have the Apple and the Google at 0.5 each. Okay, so this is now our port spec. Third, let's take a look at the objective. The objective can either be minimizing risk or maximizing returns. Okay, so we're going to use the add that objective function. If you're maximizing the returns, then you type the return. And then if you're minimizing the risk, then you type risk. Okay, first, let's just focus first on risk minimization. So we're going to create another special object. We'll call it port mean variation. So this is our objective, and it will be equal to port spec 1. Okay, so remember, port spec 1 is a list. There are many objects there. So we're going to use the elements of port spec 1 as elements of port mean var. And then we're going to add the objective in this object port mean var. Okay, add objective. Our portfolio again is, this time it's port mean var. Okay, what does port mean var contain? It contains the elements in port spec. Okay, and then we identify the type. The type is risk, since we're minimizing risk. And the name is standard deviation. This is the measure for the risk, standard deviation. So let's run this, and let's see what port mean var contains. Okay, so port mean var contains port spec 1. It contains the assets, it contains the constraints, and it contains now the objective there. The objective it's a risk objective. Okay. It's minimizing risk. So this is our port mean var. Okay, so it's like the port spec 1. However, dinagdagan natin we added something to it. Okay. All right. So, okay. Step 4 now is, let's now optimize the portfolio. Since we are now able to define our portfolio specification, we can now optimize it. So what does the optimized portfolio do? Okay, this function aims to provide a wrapper for constraint optimization of portfolios that specify constraints and objectives. So it will compute now the optimum portfolio. Okay, R is our assets. Then we have the constraints. Then the method. The method can be, okay, we can use all the methods here. We can use all the methods, or we can just, for our purpose now, we'll just use one. For your paper, I suggest that you look at the other methods also. You can do this, C, and then other methods, and it will give us the optimization using the other methods also. Okay, so this one now is optimization. Okay, so take a look at this. Optimize that portfolio. So we're going to use the mean var. A while ago, we used mean var, port mean var, okay? No, wait. What was the was that the name that we used? Okay. Yeah, port minimum variance, portfolio minimum variance. Now we're going to create an object. It will now be mean var opt. This is now computing for the optimal portfolio. Okay. So optimize that portfolio. So what are the elements here? Okay. First, R is equal to our assets, port 1. Our portfolio is equal to the port mean var, which we created a while ago, the one with objectives, and the optimize method. Okay. For your project, you can, as I said, you can use several methodologies. Here we're just using random. Now, since this is random, let's set that seed to a particular number so that we have the same solution. Okay, so let's now set the solution, set that seed, and then optimize the portfolio. Let's run this. There. Okay, we now have this object mean var opt. Okay, I'll run this mean var opt. I'll view this. So what does it contain? Okay, it's still running. Okay, it's almost time, guys. May I have just a 5 to 10 minute extension, guys? Is it okay?
Yes, sir. No
Okay, thank you, guys. We'll just finish the risk minimization so that you can now work on the next part, which is returns maximization. All right. Okay, what happened here, guys, when we run the optimization? Take a look. Leverage constraint, okay, are restrictive because we use full investment, which means we require that the total weight should be 100%. And sometimes it happens that this is quite restrictive. So it suggests that just make your minimum weight to be 99% and maximum weight to be 101%. So let's change that. Let's go back to our model here. Okay, this one, guys, this one, the port spec. So what I'm going to do, I'm going to remove the hashtag here, remove the hashtag, and then put the hashtag here on the first one. Okay, so we'll just make this as a comment. So this one is now a comment. It should be part of the, okay. So comment na lang tong full investments. And this time, what we did here, we're now using not full investment, but weight sum. Okay, so minimum sum is 99%, maximum sum of the weights is 101%. So let's run this. Run, okay. Run port spec 1, run port min var. We have to run this again, what we did a while ago. Okay, after running port min var, let's run now the, run now the optimization. Okay, we're now ready to run this. This one. The first step, guys, is the portfolio specification. The second one is the objectives, and this one, the optimization. Let's run this. Okay, let's wait for the optimal solution. Okay, it's running. So it's coming, it's trying to, there. So let's see, guys, the, let's view first. What can you find here? Okay, so there are now several objects here. You now have here objective measures, okay, which means that you have the computation for the standard deviation. Take a look. You now have the computation for the risk portfolio, for the portfolio risk, I'm sorry. It's 1.6%. Okay, you also have the optimal values. Okay, that's the optimal value is the standard deviation. Okay, the call, what's the call here? It's the, it's a different functionalities of your optimization. And then portfolio, you have the constraints, objectives, and then the data summary, etc. Okay, so these are now the elements of your min var optimization. Okay, what names? Let's get the so we have the weights, the optimal values, portfolio, etc. Okay. So this min var opt, this is your object that contains all details about your optimization. Okay, so we can get the weights. Okay, so either use extract weights function of the min var opt or min var opt1, and then let's subset the weights. So let's run this. Okay, so what do we have now? What is this saying? It's saying that your Apple should be 32% and your Google should be 67%. Take note that the sum is 99%. Okay, it's not 100%, but that's okay. Okay, 32% for Apple, Google is 67%. Our initial, what we did a while ago was just 50-50. We did not have any basis for that. And what we're being told here is that if instead of 50-50, if you want to minimize the risk, then what you do is what am I saying? What you do is to use 32% and 67%. Okay, let's try to compare, guys. No, let's also extract. Let's extract the objective measures. here. Okay. So the risk of the portfolio, the standard deviation is 1.6%. Okay, so same lang tong codes na to, no? It's 1.6%. Okay, let's, where's our object? Our object is port 1. Where's port 1? Port 1. Let me just show you guys if, so it's Apple, right? Port 1. So why don't we get the standard standard deviation of the returns of Apple? Oops, wait, so this is in port 1. So this is in port 1 object. Port 1. Okay. So I'm using the port 1 object. Okay, in port 1 you have the Apple returns. I'm asking R to compute for the standard deviation, the risk. Enter. So that's 1.9%. So our portfolio had a lower risk than Apple. Okay, so let's compute also for the Control C, Control V. Oops. Let's compute for the risk of Google via the standard deviation. Enter. Okay, what was the standard? What was the risk of Google? Okay, remember, port 1, guys, is the XTS object where we have the returns of Apple and Google, the one that we're using for our portfolio. The risk, the average, the risk of Apple as measured by standard deviation for this 1,257 observations is 1.9%. For Google, it's 1.7%. For our portfolio, it's 1.6%. Okay, so see, this validates the theory of Markovits that the riskiness. That's why we have a portfolio. That's why we put on, we diversify because it can minimize risk. Okay, just a few more, guys, before we call it a day. I'm sorry about that. Okay, so, oops. Okay, a few more. Okay, then we can also plot the chart of our mean var opt. Let me just show that. Okay. All right. So this is 32% Apple and 67% Google. We can, of course, make use of other, the color set. This is color brewer. Okay. I'm sorry, I don't have time to discuss this, but you can research on color brewer. These are different colorings. We can use in R. Okay, so if I run that, okay, guys, I was able to change the color and put some titles there. This is a better presentation as compared to this one. Okay, so you can plot. And you can also look at the performance of the portfolio. So here I'm creating an object mean var perform 1. Okay. This one, guys, we're getting the return of the portfolio from our port 1 objects, but the weights is not 50-50. Okay. What are weights? Our weights is the extract weights of mean var. This is the 0.32 and 0.67. Okay. So let's plot this. So ito na yung portfolio returns natin. No? So which means we're multiplying the returns of Apple and Google by 32% and 67% respectively. And then this is the chart performance. Okay, let's take a look at that. Okay, anyway, let me rerun this. There. Okay, here we have the cumulative returns. Means you add the returns on a daily basis, and then this is the daily return, and this is the drawdown. I hope you discussed drawdown in your portfolio management. If not, guys, just Google the drawdown. It's easy to know what the drawdown is because I'm really running out of time. Okay, just this last one, guys. Okay, Okay, now I'm sorry, I have to check this kasi nag-error pa ako dito, no? Just skip that. Ito din may error pa ako dito. I'll just go to the last one. Okay, this one, guys. Ito. So what's this? Ito yung may rebalancing, no? So this one, mag-optimization tayo with rebalancing. We'll use quarterly rebalancing. Okay, so ang kaiba nito, optimized portfolio, may rebalancing na. No? So ibig sabihin, magbabago na yung mga weights natin. We're going to use the port mean var1, still the same, random pa rin. Kaya nag-set that seed ulit tayo. And then we have training period and rolling window. I-discuss ko na lang to next time, yung mga specifics niya. We just want to run this now. Okay, kahit ito na lang. Okay, I just want us to compare, guys. Okay, tapos i-extract na natin yung weights nito. Extract weights natin ng rebalancing. Tapos na ba? Okay. There. Okay, what happened, guys? So you notice sa rebalancing, di ba parang kanina, nagbabago yung weights. Okay, since nagre-rebalance tayo, the weights will change. Yan, Apple and Google. Right? Okay, and if we chart this, chart natin tong rebalancing, take a look at this. See? Yan. Yan yung distribution. Quarterly changes in the distribution between Apple and Google. Okay, so we'll stop there, guys. So please continue this on your own. Ito naman yung yung returns, maximization ng returns. So parang naulit lang siya pero mababago lang yung objective natin. Kasi kanina risk minimization lang. Okay, so let me stop now the recording. Stop recording.